Alright everybody, welcome back. This is Unit 3, Video 5. It is the last video of the unit, and hopefully we'll get you through it pretty quick. So let's begin. We're going to go over ions and their chemical configurations. So first thing you need to know is what ions are, okay, and how they are different from an atom that we would normally talk about, okay. So ions are changes in the number of electrons in an atom. What this means is that an atom has lost or gained electrons. Once they lose or gain electrons, they become the ions. All right? So if the number of electrons is less than the number of protons, in other words, electrons are lost, making their the amount of protons greater, then there is an excess positive charge. Makes sense. More protons, more positive. Okay? If this is the case, it's known as a cation. Okay? Then we have if the number of electrons is greater than, right here, the number of protons, in other words, there's more negative charge, electrons are gained, then there is an excess negative charge, and it is called an anion. Okay? One way I try to help my students remember this is thinking of it this way. If I lose, like right here, if I lose my negative charge, in other words, if I lose my negative friends, what's going to happen to me? Well, in my experience, if I get rid of my negative friends, then I'm going to become a more positive, happy person, or a happy cat. I'm going to be one happy cat if I lose those negative friends, okay? And if I gain negative friends, I'm going to be sad and I'm going to be crying because I'm now going to be a negative person, kind of like an onion would make you cry, okay? So I try to think of this as kind of like an onion, okay? But it really is called an anion. All right, so that's just a little way to help you remember to think about that. All right, so moving on. Let's do a couple practice problems. So the sulfide ion has a charge of -2. This tells me right here that something's going on with my electrons. All right, so how many protons and electrons does this ion have? Well, because it is sulfide ion, we know that this is sulfur from the periodic table. You need to remember that protons are always the same for an element, okay, whatever element you're on. Always the same for that element. So the number of protons for sulfur is 16, and it always will be, okay, so 16 protons. Now, in a neutral atom, we would normally have 16 protons equals 16 electrons. However, because of this charge right here, we now know that this is no longer the case. Okay? So when I have a -2 charge, this is showing me that I'm actually gaining 2 more negative friends, so to speak. Okay? So that would mean that I now don't have 16 electrons, but instead I've gained 2, so I'm at 18 electrons. All right? Meaning because I've gained -2 charge, that my sulfur would have a -2 charge. All right? Number 2, an element has 20 protons and 18 electrons. Identify the element and determine the ionic charge. Well, if we know the number of protons, we know the element. For 20 protons, anytime you see 20 protons, it's going to be calcium. Okay? So, now it wants us to determine the charge. Well, remember, in a neutral atom, it would be 20 protons equals 20 electrons. However, we can see right here that this number, 18, and this number, 20, are no longer the same. Therefore, we know this must have a charge of something. Well, did I lose or gain electrons? Well, I lost electrons. If I lose electrons, then I become more positive. So I lost a total of 2, so I have a 2 positive charge. Okay? And the last one, I'm going to let you give that one a shot, and we'll get you the answers in class for that one. All right? So, moving on. All right, so chemical configuration and nuclear symbol. You have to know how to write these chemical configurations, including the ionic charge if there is one. All right, so first things first, the atomic number equals the protons. So in this one, we can see right here, atomic number is equal to the number of protons. Okay? Mass number, ooh, it's kind of messed up on me there. Mass number is equal to the number of protons plus neutrons. So all you really have to do is substitute it into that equation, and you can determine your number of neutrons. We know protons. We're given a mass number of 16. All right, so because of that, we know that 16 equals 8 plus n. So how do we determine the number of neutrons? Well, neutrons would equal 8. You simply subtract. I don't know what is going on with this thing. You simply subtract in the equation that you have plugged it into. All right? Next, again, we've talked about protons equal electrons when it is a neutral atom. So normally it would be 8 protons equals 8 electrons. However, we do need to notice this oxygen is not neutral. How do we know that? Well, we can see the -2 charge right here. Okay? So because that oxygen is not neutral, we know that our electrons and protons will not be equal. So because it's a 2 negative charge, we know that it gained 2 negative electrons. Therefore, what once was 8 electrons has now become 10 electrons. Whoa, I don't know what is going on today. This is spazzing out on me, guys. Sorry about that. Okay? So, but just remember, whatever the charge is, if it's a negative charge, that means you're gaining more electrons. If it's a positive charge, that would mean that you're losing those electrons, okay? Those negative friends, so to speak. All right? So, next I want you to give this chart a try here and try to determine what element it is that you're working with. So go ahead and pause it, give it a try, and then I'm going to come back with a few of the examples for you. But I want us to be able to make sure we understand these on our own as well. Okay, so go ahead and pause it. Okay, so this first one here, key indicator you need to recognize is that we already have the number of protons. So you can go ahead and start by telling me what the element is. So for a proton number of 5, we look at our periodic table and we see that that is actually boron, okay, which is a B. All right, so next step, we look at our electrons here and we see, well, 5 and 5. That means this must be what? Oh, this must be a neutral atom, okay? So it's not going to have a charge of any sort. So we don't have to write anything up here in the corner, okay? Then we see our neutrons is 6. Now it wants to know the mass number. Well, you got to think back to your formula when you're looking for mass number. That is going to be your protons plus neutrons, okay? So if we've got 6 neutrons, 5 protons, then that's going to give us a total of 11 for our mass number, okay? What is the atomic number? On the previous slide here, we just said the atomic number is the same as your number of protons. It's just another fancier way, I guess you could say, of saying how many protons do you have. So it's 5. All right, so then it asks for charge. Like we said, we see that it's 5 and 5 for protons and electrons, so it must be neutral. Therefore, we don't have a charge. Okay, so my nuclear symbol is going to be basically the B, except you want to write in your mass number and your atomic number, okay? So your mass number is going to go here, 11, and your atomic number is going to go here, which is 5. All right? All right, the next one, we can see on this one that we are not given protons, so we're going to have to do a little thinking on this one, okay? So we do, however, have a mass number of 14 and a neutron number of 8. Well, what is the equation you know? Well, mass number equals protons plus neutrons. So can we figure out protons? Absolutely. We can take this 14 here and say 14 minus 8 is going to give me my protons. So 14 minus 8 is 6. Now, did we want to just go ahead and say, because it's 6 and 6, that 6 protons, 6 electrons, that we can assume it's a neutral atom? No, we want to make sure first, because the electrons might have changed for another atom. All right, so once you figure out your protons, now we can say for sure what element it is. So if we look on our periodic table, we can see that the element is carbon. All right, so we're going to write in a C for carbon. Okay, now atomic number, remember, is the same as protons, so it's a 6. And charge, we can still see that happened to work out that this is. All right, so we know that there is no charge on that one as well. All right, so it would be carbon 14-6. All right, and then your next one, I'll do that one with you. So if you look at mass number, we see is a 32. I think think we should have been given this right here, because it already gave us our charge, and we're going to go 32, 16. Okay, so from this we can see the atomic number is 16. All right, and then if we know the mass number is 32, all we have to do is subtract 32 minus my protons is going to give me neutrons, which is 16. All right, my atomic number also the same as my protons up here at the front. So 16, and then we could see this has a -2. That means I've gained negative charge. Therefore, I'm no longer 16 and 16, but I am now 16 with 2 more electrons thrown in there, so it's actually 18. Okay? So, I want to encourage you to finish these last two, check them over in class, and if you need to, head in for tutoring. We're here to help, so let us know. Hope you have a great day, and thanks for watching.